Welcome to Automate and Learn with Yogesh. Today here we will learn about Amazon S3 tables. So let's start the video. So what is Amazon S3 tables? First of all, we will learn about Amazon S3 tables as well as a practical hands-on uh, by creating a S3 tables as well as dumping some data in it and querying that table as well. So what is S3 tables? It usually refers to a table-based data storage. Right? It's built on top of Amazon S3 bucket, which is not actual relational tables inside S3. So first, the key idea is Amazon is an object storage device. You put objects or files inside it. So basically, it stores objects, files, and not database tables. So in order to make so, when people say S3 tables, they usually mean that data is stored in S3, but it is organized in a table format for analytics, typically using Apache Iceberg, Delta Lake, and Hudi. So in our case, it's Apache Iceberg S3 tables over here. So as per modern AWS architecture, they are analytics tables stored on S3. So where data lives as files in S3, it may be in Parquet format, ORC or JSON format. A table layer is added on top of S3 bucket using metadata. So query engine treat it like a database table. So basically it's a table inside an S3 bucket. So it performs like a database and the tables from where we can add some data inside it and you can query on it the table. So how it works? So basically we have a storage layer over there where data files are stored in Amazon S3. Usually it's in columnar formats like Parquet format. Then we have table format layer. Here we have Apache Iceberg, as we said. It's most common. These provide some of the features like schema evolution, time travel, that is versioning, as well as asset transactions. Then we have query layer. So in this you have Amazon Athena. So on build, it's on basis of Amazon Athena, we can query the data like a table using Amazon Athena services like SQL query on top of it. Similarly, we also can have Amazon Redshift via Spectrum or some external tables. We can also compatible with Spark, EMR, as well as AW Glue data catalog. So why S3 tables are used? It basically solves the problem for no schema, no updates, hard queries, no versioning and data duplication. The solution basically use Iceberg table schema, asset transactions, SQL engines using Athena. We have features like time travel, compaction, and many more. So basically we have, this is a pretty simple example. We have a S3 bucket. Here we have files, file 1 and file 2. So when we create a S3 table, right, on top of Iceberg, here we have customer table, partitions, schemas, snapshots, and Parquet files inside the S3 bucket. So basically you can write a SQL query like select star from customer table where some condition like maybe depends on your column name. Here in case is equal to India, country is equal to India. So some of the key concepts you must know. Basically, Amazon act as promoting S3 tables as a managed Iceberg based table service. So where it act as the storage, right? Iceberg act as a storage. So you must know about it. So in one line, S3 tables is equal to S3 plus Iceberg plus SQL engines like Athena. That is equal to database like objects on object storage. So first of all, what is Iceberg? Iceberg is an open table format. Is basically used for managing large data sets, right? Yes, it's stored in data lakes like Amazon S3. So think of it as a table layer that turns in S3 into your real database like system. So it converts the table like into real database, right? So Iceberg is a table format. It's basically used for huge data analytics data sets that sit on top of the object like Amazon S3. So Apache Iceberg is also a table format for data lakes. It has petabyte scale, like it can scale up to petabytes. Originally from Netflix. Yeah, you heard it right. It was originated from Netflix. So we have some more key concepts over here. It does not store data inside. Instead, it manages metadata, table schema, as well as file organization and query consistency. My bad. Then we have some analogy over here. So with simple analogy, S3 that is equal to warehouse where you can put all files or objects inside it. Iceberg that is it's a inventory system plus catalogs. Athena where you can query the database, that is workers who read it. Some of the key concepts of Iceberg: ACID transactions. It supports insert, update, delete, rollback, and even on S3, which is just object storage. We have schema revolution. You can add, remove columns, rename columns without breaking all data. So that is possible over here. We have time travel. So basically versioning is enabled. You can query past states. What did my table look like yesterday? So if you have made some changes in that table, so that is possible using versioning. Then we have fast querying. Iceberg tracks metadata, so engine skips unnecessary files. So here we have faster scans, less cost in queries. Then we have hidden partitioning. Hidden partitioning like update partition schemes and data volumes, right? So it's used by Amazon Athena, AWS Glue, Spark, Redshift, etc. for as an integration purpose. So it also has compatibility on works with Spark, Flink, Trino, Pestio, and Hives, etc. So here is some key concept, like instead of reading all files, S3 the Iceberg basically maintains metadata layers. So this metadata file is manifested in list and data files that package in S3. So this is a basic layout of it. Then query engine knows which files to read first of all, which to skip, which version to use. So basically, as versioning and many features are enabled, so this thing is enabled over here. So these are Iceberg. What it does basically fixes all of that, like previous issues, and making S3 behave like a database table system. So you can think of it as like it's a database, right? Some of the features over here better than just storing data in S3 buckets, up to 3x faster performance, 10x more transaction rate, right? So but it's slightly more expensive as you have Iceberg and many Athena like services involved in it. So it's slightly expensive. Manage table optimization. Table optimization is done by system. Compaction is available. We have snapshot management. So in order to have some backup AWS, so you have a snapshot. You can take a snapshot of that data. Unreferenced file removal. If you have unreferenced file, you can remove those files. Then IAM as well. IAM and service control policies. You can control your files and objects in your tables. Then we have table buckets. So let me show you what a table bucket means. So this is basically our table bucket. So we have a namespace. Think namespace as a term like database. It's similar to database. Suppose you have this table bucket, you will have to create a namespace over there, and inside the namespace, you will have some tables, table 1 and table 2. Similarly, you can consider a namespace B, namespace C, like multiple namespaces and table inside those namespaces. So namespace basically you can term it as database. Think it in terms of database. Okay. So here we have access resource names. ARN also go under S3 namespaces, S3 tables namespaces. Namespace I already said you, like think in terms of database. This is a sample example. Like access resource name would be AWS S3 tables, then your region, then your account owner ID, then bucket/bucket name. So this format should be your ARN. The table contains tables which may be organized to namespace. Okay, and this is the same concept at databases. As I said, namespace, like we can think it's similar to database, which contains multiple related tables. Okay, so we have here two types of table buckets: customer managed, and second one is AWS managed. Here it has S3 metadata, inventory tables, and so on. So name only needs to be unique within your account, not like S3 bucket where you have global namespace name convention. So here, but it has one thing, like must be lowercase. The table bucket must not have uppercase in it. It must be lowercase. Think while creating a table bucket, it must be notified or noted or won't integrate with lake form or glue formation. So the name must be lowercase. Same restriction on namespaces. While creating namespaces, it also must have a lowercase inside it. And the thing is, it cannot be changed, right? Once it's named, it cannot be changed. And then we have IAM policies attached to it. You can also have tags attached to it if required. Then we have intelligent tiering. Intelligent tiering is basically like storage class. You can change the storage class of the bucket. By default, it's standard. By enabling or selecting the intelligent tiering, you can have a certain period like when the unused objects are there. So the storage class will be changed automatically to lower version, or the depends upon your selected storage class. Then we have table replications. Like if you want to replicate the table, so this is also doable. It has also automatic replication for backup as well as availability compliance. If you want to do so, you can do in the S3 tables. Read-only replicas, that is also possible across multiple regions or across accounts. Then use cases, minimize latency with local replicas, centralize analytics if you want to do until analytics at a central level by replicating it to a single region. Then we have compliance or data residency where it can be used. We have certain test environment or development environment where it can be used. Intelligent tiering can also apply to replicas to minimum cost. That's what I said. Intelligent tiering means changing the classes based upon the unused data, which if the data is left unused for much more time, depending upon the days which you have selected, so the storage class can be changed. We have S3 table securities over here. This is very vital for this. The standard tool applies to table buckets and policies. Like we have IAM security based policies where you can configure user, group, or role. Resource based policies, right? Then Amazon organization service control policies, SCPs. Other access management tools like SQL commands. Like basically you can query the query. So SQL commands, depending you have operations mapped to specific IAM permissions. We have lake formation, encryption. As I said, you can set encryption. Default encryption is SSE S3, or also you can have an option to select with KMS. Then we have VPC endpoints via private link. We have gateway and interface endpoints for finer grain control where access is needed. Like security is very vital and fine grain is needed. Endpoint policies may restrict by table or bucket. Then we have dual stack IPv4 as well as IPv6 endpoints. The one more thing which is highlighted over here is public access and HTTP not allowed. So whatever may be your S3 bucket, table bucket, don't have public access and HTTP, which is not allowed over there. Then we will now go to our S3 portal. So here is my S3 portal over here. So when you go to S3 now, here you have buckets. So under buckets, you have table buckets over here. So let's click this table buckets. When you go over here, here you have orange icon, create table bucket. Let's create a bucket over here. So you have a naming convention where we have to specify your bucket name. Remember, this must be always in lowercase. A capital character is not taken place over here. So let's name it as demo over here, right? So here we have enable integration. In order to work with Athena and Glue services like Amazon S3, so it must be enabled over here. You can select integration details over here. So catalog name S3 tables catalog is created with AWS Glue catalog as well as subcatalogs when you enable this checkbox. Okay, so it will be within in the same region. So currently I am with Asia Pacific Mumbai, so same region will be selected. You can enable it like checkbox enabled if you want to integrate with different services which I mentioned over in the previously in theory session. So here we have default storage classes. If you want to specify a storage class, then you can go with standard or something. If you don't specify, the standard class goes by default, so let it be as it is. Here you have default encryption. If you want to enable encryption, like if you want to specify a certain encryption, by default if you have selected disabled, the default encryption goes for it, that is SSC S3. If you enabled it, you can select the KMS or different types of encryption over here. You have option to select go with KMS. Let's disable it. So as of now, we don't need it. Also, you can add or enable tags over here. If you want to tag this S3 table bucket, you can do so. So let's create a bucket. So here, as you can see, successfully created table bucket. And here our demo is created under table buckets. So let's click it. So here we have option to create the table with Athena, right? So let's create this. So as I said, you have to specify a namespace over here. So basically namespace, think in terms of database. You can, if you have specify an existing database, like existing namespace, if you are having, you can specify it from here, from drop down. Since it's my first time, I don't have any namespace. I'm creating a new namespace over here. So let's name it as demo v1. Okay. Also valid characters are A to Z 0 to 9 underscores. Okay. Then we have we should click on namespaces, create namespace. So we have successfully created this namespace demo v1. So we have successfully created the namespace. So now to create the table now, we have to click on this create table. Here we have to specify, since we have already created namespace, we have to specify our existing namespace. We have already created demo v1, right? So here we have demo v1. You just select demo v1, the namespace which you have created earlier. Create table with Athena. So here you can see the new interface or new portal has been open. Let me zoom it. So on the left hand side, you have data column over here. So in this, you have data source. You must notice that your catalog, this catalog must have this S3 tables catalog and the demo, like the table bucket which I have created, S3 tables. It's demo, right? So this must be properly selected, which you have already selected earlier. Then we have database, under which we are working, data demo v1. So catalog and demo database, like demo v1. You must ensure you are working under correct database or the Athena namespace. Okay. Then here you go on the right hand side. Here you have workspace over here. Here you can write sample codes. So sample code is already written over here. All right. So when you scroll up, here you see a table properties over there. So table properties, that is, you have to specify table type, which is iceberg. So this must be specified in the SQL code only while writing the create code. So we have some sample code over here. So what we can do, we can just copy this create section. This will help to create a table over here, like table demo v1, and inside it will create a daily sales table. So here we have plus icon. Just click on it and paste this code, and here you have run icon, right? So one thing you will notice here, we have grade run icon is great. Why? Because we haven't set our query settings, like the tables which we create, this needs to be stored in somewhere, like at some location, right? So we will specify that location over here. So we are into query settings. Here we will go to manage. Okay. So here we have basically options to locate your query results. So we will specify our S3 bucket. Here you can create your bucket or you can specify any bucket. So I have already created an existing buckets over here. I will specify this demo v1 bucket for as of now. I will choose this bucket and I will save this bucket over here. So once I have saved, I will again go to editor. So here you see our run uh, like button is now orange icon. It's not grayed out. So now we can run our queries. So what we did, we just specified our S3 bucket location. So now let's run this query. See, the query is running. Query successfully completed. So now when you see on the left hand side, this has created a daily sales type of table. Inside it we have sales data, product category, sales amount. Then again what we'll do, we will insert some sorts of values inside it. Just copy this boiler code over here. We can paste it in new editor table over here. Editor working window, sorry. So we will what we'll do, insert these types of values inside it. So let's run this command. Query completed successfully. So that is, this data is dumped into the table. So now what we will do, we will uh, try to query our table. Now let's again open this new tab, paste this query. So this is a sample select star query. Select product category count sum, and where condition is specified between some date range. We will try to query this. So as you can see, we can able to fetch the records which is present in the table in between this date range and where condition. So by this we have learned, we have created a S3 table bucket. We have created a namespace. Under namespace, we have created a table. We have inserted some raw data inside table, and we have queried our data from that table. So that's all for today. If you like my video, stay tuned and subscribe my channel. Thank you.